There's one more case for us to take a look at when dealing with Le Chatelier's principle, and this is the effect of adding a noble gas when you have a constant temperature and volume. We have a reaction here for the breakup of N2O4 into NO2, and we're asked to predict the direction this reaction would shift if you were to add a noble gas at constant temperature and volume. So by saying that temperature is constant, that means that we don't have to worry about the effect of temperature on equilibrium. We don't have to think about exothermic or endothermic. And because volume is constant, we don't have to think about, how many moles of gas there are, shifting to a side that has more or fewer moles of gas. Let's think about the effect that adding the noble gas would have at constant T and V. To do this, it might be beneficial for us to think about either the K or the Q expression for this reaction. Maybe I'll write the QP expression for this reaction. Pressure of NO2 squared over the pressure of N2O4. And if adding the noble gas causes the pressures of N2O4 or NO2 to change, then we would have to have a shift in the equilibrium for this reaction. Now, because temperature is constant, that should help keep the pressure constant. Because volume is also constant, that should also help to keep the pressure constant here. So by adding a noble gas, that is going to have absolutely no effect on the amount of NO2 or N2O4 that is present. Noble gases, like things like helium, neon, argon, these are unreactive gases, so it's not like the addition of the noble gas will cause a reaction to occur that removes NO2 or removes N2O4. The noble gas is just going to be hanging out there in the container, and it's not going to have any effect on the NO2 or the N2O4. So what we'll say is that because adding the noble gas at constant T and V has no effect on the partial pressures of NO2 or N2O4, there's no shift in the reaction because there's no change in the value of QP, and so the reaction just remains at equilibrium upon the addition of the noble gas. There will be no change in the equilibrium when you add a noble gas at constant T and V. That brings us to the end of chapter 6. And at the end of every chapter of general chemistry, those of you who have been in my classes in the past, you know that at the end of every chapter, I provide a bulleted list of topics that we went over in this chapter, and you could take a look through this in these slides or also in the slides that are posted to Gaucho Space so that you can see what we covered in chapter 6, and you can use this as a little bit of a study guide for preparing for exams in the class. So that's chapter 6, and we'll get started on chapter 7 next when we begin discussing acids and bases.